Hello everyone. Yesterday I saw a video of Mr. Neil deGrasse Tyson. Mr. Neil in that video talks about God, statistics, probability, and our inability to understand it. I will leave the link for the video in the description. You can watch it for more reference. As Mr. Neil says, line up 1,000 people and flip a coin. Whoever gets the tails, he sits down. Repeat it and there will be one person standing at the end. But praise will only talk to the person who wins, assuming he's special. And his response will be he felt it, he was about to win. But the praise didn't ask the other people who lost and might have felt the same about winning. But according to Mr. Neil, he's not special because every time we flip the coin, there always be a new winner. So I thought we will do this experiment in Python. I will create 1,000 people and toss the coin until we have a winner. There is this catch though. Contrary to what Mr. Neil says, we might not get a winner at the end. That I'll explain now. Suppose we have 5 people left at the last round and all the 5 people get tails. So nobody actually wins. And we will include that in the experiment as well. We will have 10 games and 10 winners. And we will see if the hypothesis provided by Mr. Neil is accurate or not. So here is the code. So these are the libraries I am using. I am using names to generate 1,000 people or more. We are using random for heads and tails. We are using time, iter tools for dictionary modification, and pandas for the data analysis. So here are the inputs we are giving. So we are giving heads and tails for coin toss. So total people we can decide. For now I am giving as 1,000 people, and we will have 10 games. So it's showing as repetition as 10. So at the beginning of the program we are creating 1,000 unique names with the first coin toss. So I'll actually show you as we go along. So let's import the libraries. Let's process the inputs. So we will create 1,000 names and we will have first coin toss as well. So because the output will be a lot bigger, that's why I'm commenting out the output. We will go forward. So the dictionary length is 1,000. In that dictionary, so each key will have a value, heads or tails. So this is the data frame. I am creating a basic data frame first and we'll append the winners to this going along. So this is the remaining coin tosses and the eliminations as well. So first the program will eliminate the people who got tails in the first coin toss, and it will continue to do it until we have one winner or nobody wins. So let's process it. And this is the data analysis. So I have created a pivot chart. As you can see, I have processed it. So this is the basic pivot chart, and this is in a bar format, so we can understand. So the number of games took place is the 10, and we have 10 winners. So nobody won one time, and other people also won one time. So here we can see in the bar chart. So actually Mr. Neil is correct. So here it's just showing 5 because I have given heads value as 10. We can give it 10 and process it again. So see, we can see all the 10 winners. So nobody just won one time, and other times we have a winner, different winner, basically different winner always, as Mr. Neil says. Now as we have seen what happens with 1,000 people, let's let's try for 2,000 people and let's see what's the output. So we will get more data and we can process it and we can understand probability much better. So let's do it for 2,000 people. and we will have 20 games this time. Okay, so I will not do it individually. Let's run all the cells together. Perfect, we have results. So number of times game took place is 20. Okay, so here we have a big difference. This time nobody won 7 times, and all the other people won one time. So basically, even if we test it on larger scale, Mr. Neil is accurate. Every time there will be a new winner. We can just try it for more people though. I think there should be one time at least where someone wins repeatedly. I think I think sometimes luck also favors a human. So what I think is, let's try it for 5,000 people, and we can have 50 games. That's fair. And let's run whole program once again. Start and run all the cells. Now it will take time for processing the program. So basically it does take time to process 5,000 people, as we are generating the names from the scratch. We are not using the previous 2,000 names. We are generating them from the scratch. So it does take time. Okay, so we have result. Surprisingly, nobody won twice. So yeah, I think there's very slim chance, even if we did more games, there's very slim chance that people can win twice. So you can see everybody. So these I have actually sorted out with the top values. So nobody won 20 times. So if somebody would have won 2 times or 3 times, it would have shown here. Um, but we only have winners one time. That's still good though. So we did the experiment. Please let me know if you want a part 2 of the video, where we implement some mathematical formulas at the end, and we can see what was the probability for each person to win and how we performed accordingly. If you like this video, please hit the like button and subscribe to my channel.